Hello, and in this video we're going to be looking at modelling with volumes of revolution, so building on the examples we did in the previous video. And to do this we're going to look at two exam questions from the Core 2 paper, one about a vase and one about a berry. So this one is about the vase. Figure 1 shows the central vertical cross-section A, B, C, D, E, F, A of a vase together with measurements that have been taken from the vase. The horizontal cross-section between AB and FC is a circle with a diameter of 4 centimeters. So imagine rotating that shape around, and that's what we will trace out. The base of the vase ED is horizontal, and the point E is vertically below F, and the point D is vertically below C. Using these measurements, the curve CD is modelled by the parametric equations x equals a plus 3 sine 2t and y equals b cos t, with t between 0 and pi over 2, where a and b are constants and O is the fixed origin. This question had 3 parts, which we'll look at in turn. Part A was 2 marks. Determine the value of A and the value of B according to the model. So when we substitute t equals pi over 2 into x, we get x equals a plus 3 sine pi is 0, so x equals a. And when we substitute pi over 2 into the y equation, we get y equals b cos pi over 2, where cos of pi over 2 is 0, so y equals 0. So on that basis, this must correspond to point D, which has a coordinates of 2, 0. Hence, if x is a, then a must be 2. That means that where C is will be the other end when t is 0. So substituting that into the equations, we get x equals a and y equals b. And as we know that it's 7 centimeters from the x-axis, that means that b must be 7. So we're using the formula v equals pi times the integral of x squared dy and parametric equations, parametric integration. So we already know that x equals 2 plus 3 sine 2t, which we need to square. And we also know that y equals 7 cos t. So we're going to be replacing dy with minus 7 sine t dt. So multiplying those together, taking out the negative 7 as a common multiple. And then we end up having to integrate 4 sine t plus 12 sine 2t sine t plus 9 sine squared 2t sine t. And then in blue underneath, I have expanded 12 sine 2t sine t and 9 sine squared 2t sine t to put them into a form where I can then integrate them. So in the first case, I've got 24 sine squared t cos t, so I can substitute for sine t. And in the second case, I've got 36 cos squared sine t minus 36 cos to the 4 t sine t. In both cases, I can substitute for cos. So this is me integrating all 4 of those terms. I'll let you pause the video to read them through. And then at the top of my solution here, you have me substituting in 0 and pi over 2 to get 588 fifths of pi. Then we also need to add the cylinder on top, which has a radius of 2 and a height of 4.5, giving us 18 pi. So the total volume is going to be given by the sum of those two things, which is approximately 426 centimeters cubed. Just for confirmation, here is the mark scheme for that particular part of the question. Part C asks for a limitation of the model for 1 mark. I won't read them out, but as you can see, there's several possible answers they would have accepted. And now we're going to look at the berries question, which was Core 2 2023 question 7. So we're given a graph. We're told that John picked 100 berries from a plant, and the largest berry picked was approximately 2.8 centimeters long. And then the shape of that berry was modelled by rotating the curve with that crazy equation about the y-axis through 2 pi radians. So because we're going around the y-axis, we're using pi integral of x squared dy. I need to make x squared the subject of the equation, which I've done there. So I'm integrating pi over 16 multiplied by 6 minus 3y squared plus y cos of 5 over 2y. Integrating 6 and minus 3y squared is easy enough, but I need to use integration by parts, IBP, to integrate y cos 5 over 2y. I've shown you how I've done it in blue, and my answer was 2/5 y sine 5 over 2y plus 4/25 of cos 5 over 2y. So substituting in our values from the y-axis of 1.257 and negative 1.545, I get an answer of about 2.26 centimeters cubed. Once again, for confirmation, here is the mark scheme, and again you can see it says 2.26 centimeters cubed at the end. And then for part B, we're told that the 100 berries that John picked were then squeezed for juice, and we're asked to use our answer to part A to decide whether, in reality, there's likely to be enough juice to fill a 200 centimeters cube cup, giving a reason. Well, I mean, the mark scheme is there. If all the berries were 2.26 centimeters cubed, then that would make 226 centimeters cubed in total. But then that's the largest, so we'd expect the rest to be, smaller than that. Some will be smaller than 2 centimeters cubed. And also they've decided to mention the fact that not all of the berry will become juice. So, for example, the skin, the flesh, and the seeds, etc. So, yes, I'll leave that with you. Thank you.